Good morning students. This is Digital Communication Unit 4, that is binary frequency shift keying. So, frequency of the carrier is varied to represent digital data, that is binary 0 or 1, that is a digital data. So, peak amplitude and phase remain constant. B of t equal to 0 represented by high frequency, then B of t equal to 1 represented by low frequency. If B of t equal to 1 at a time SH of t is a high signal, that is root of 2 ps cos of 2 phi f naught plus that is the ohm t or theta t. If beta t, if B of t equal to 0, that is we can say SL of t at a time root of 2 ps cos of 2 phi f naught minus theta or ohm t. This is then FSK output is given by, we have to add it to B of t 1 and B of t 0. So, we can say that is S of t. So, S of t equal to root of 2 ps cos of 2 phi f naught of dt then theta of t. So, see the diagram here, the 1 is the closed signal and 0 is the elaborate of the signal. So, then TB is the bit period. Okay. So, next one see the 1 0, next one we see 1 1 is available now. So, at a time all the signals are very closed. Then another one we see 0 is available, the elaborated. So, next one is 1, that is the signal is very closed. Then 0 0 is finally is available, that is the signal is largely elaborated. Okay. This is the frequency shift keying normal general diagram. Next we see about a BFSK transmitter section. Here the B of t input sequence is available, here the inverter section, then the level shifter is also available. So, finally the mixer circuit, finally we get the output. See the B of t equal to input sequence means it is moved to the level shifter section, that is PH of t, PL of t. Then it is moved to the output is PS of TB into PH of t, here the root of PS TB PL of t. Then the orthogonal signal is used in the mixer stage. Okay, phi 1 of t, that is a standard orthogonal signal, that is root of 2 TB cos of 2 phi FHT. Here the phi 2 of t is equal to root of 2 TB cos of 2 phi FL of t. Finally, the two signals are combined, are added. Finally, we get the BFSK signal S of t. Let's see the theory is available. Input sequence B of t is the same as PH of t, and inverter is added to the after B of t to get PL of t. Here PH of t and PL of t are unipolar signals. The level shifter converts the +1 level to root of PSTP. So, that is why in the diagram we get the root of PSTP after the level shifter. Okay. Output of the level shifter will be either root of PSTP if input is and 0 or if input is 0. Okay. Then two carrier signal are orthogonal to each other, phi 1 of t and phi out of t. The output of modulators are not at the same time. So, if PH of t equal to 1, then output will be only due to upper modulator, and lower modulator output will be 0 if PL of t equal to 0. Upper means the higher level, lower means that is the 0 level. See the BFSK receiver section. So, BFSK receiver signal S of t. So, finally, the phi 1 of t and phi 2 of t is available. Then integrator circuit is also used here, that is 0 to 2b dt. So, then only it is divided into two ways, S1 of t and S2 of t. Finally, we get the Y of t output. So, decision device only chosen the output of the Y of t. Okay. So, that choose 1 means if Y of t that is greater than 0, choose 0 means if Y of t less than 0. This is the final output. So, the two correlators of two frequencies of FSK signal, these correlators are supplied with locally generated carriers phi 1 of t and phi 2 of t. If the transmitting frequency is FH, then the output S1 of t that is greater than S2 of t, then YT of greater than 0. The decision device then decides in favor of binary 1. If S2 of t greater than S1 of t, then Y of t is less than 0, then decision device then decides in favor of binary 0. So, this is the overall general introduction of the BFSK transmitter section on the receiver section. Thank you, students.